In this first video, we're looking at problem 8.2 in your book. But before we get to the first problem, I just want to jump back and just remind everyone of the directions, which is on the first sheet down here of the notebook. And it's this same as you had for chapter 7. You just want to make sure that you save this file as a Microsoft Excel file and submit it as a Microsoft Excel file. These problems in your book are on page between 197 and 202, and make sure that you don't delete or change anything in the shaded boxes. That's where the formulas are. And once again, if you do mess up the spreadsheet, you can always just download it from the assignment page again and start over. So this is your directions. So oh, and make sure you type your name in right up here where it says name. So follow my cursor here. So make sure you type in your name right there. Okay. And that's about it for the directions. So now let's just get into the first problem, 8-2. We're looking at the future value of money. So we're given a present value, which is $20,000 that we're starting with now today, and we're asking what will the future value of this $20,000 be in 10 years with these different rates of return, or these different annual interest rates. So the formula that we're going to be using is in your book. It's right here, and we're going to use the algebraic method, where future value equals present value times 1 plus the interest rate to the power raised to the power of the number of years. So when we're talking about interest that's compounded annually, then this end value right here is going to be the number of years. This right here, the power that we raise our 1 plus k to. So if you look at our first table here, this is the one once again where you can put whatever numbers you want to and just see what happens. And the formula, the Excel version, if you follow my cursor up, of this formula right here is in these cells that are purple. So it's right up here. So it's the same formula as you have here, as long as you put the right numbers in the boxes. So you want to put your present value here, and so I've just put in a random values, 5, 15, 60, and 120,000, and then you can put whatever rates of return you want here, and then whatever number of years you want right here. And then make sure that in the second one down here where it says enter the data from the problem here, right, that you put in the data that you're given in the problem to get your correct answers right here. And really the point to this is that if we have a higher rate of return, we're going to get our future value is going to be greater. Excuse me. So if I were to just, look at this, well, actually, I've got different values for present value, return, and number of years. But if we standardized it and just put in, let's just put in 15,000 here and just standardize that all the way through, and then say that we're going to just have a 5% rate all the way through, then you can see that the number of years, of course, makes a huge difference. The longer you wait to, the longer you let this money sit somewhere and earn 5% interest, the more it's going to grow. Now let's just compare and say, okay, we're going to start off with the same amount of money here, and we're going to keep it in for 20 years, and let's just put it 20 in for all of these, but with different rates of return. And we'll see And you can just see that with with the higher your rate of return, the more money that you're going to have at the end of the same amount of a year. So you can either, there's 3 ways you can end up with more money. You can either start off with more. So like, say for example, we started off here with 20,000 instead of 15. Obviously it would grow more because we started with more. It's going to be more, our future value is going to be higher if we have a higher rate of return, and our future value is going to be higher if we keep it in for more years, right? See, and that's really where the big change is. So if you're 20 years old and you start off with you get you get a check from somewhere for $20,000, and you say, okay, I'm going to put this in, and I'm not going to draw it out until I'm 65. That's 45 years. So if we put 45 right here, and you can see how that money is going to grow over that period of time. And obviously, if you had a higher return here, if we bumped it up to a 7, it's going to grow a whole lot more. Look at that! Wow. So look over 45 years. Look at the difference between, and let's just look at 5% is 179,700. If we just got one more percentage return, watch how that changes. It goes up by almost $100,000. So as you can see how the interest rate over a longer period of time makes a huge difference, because the curve kind of looks like that. It starts off slow, and then as the years go by, it picks up speed. Okay, so just remember, as long as you'll be fine with this one, as long as you make sure you get the right data from the problem down here, you'll be fine. Okay.